Welcome back, ladies and gentlemen. We are going to continue our discussion on vectors. Specifically, we are going to discuss orthogonal and perpendicular vectors. So the goal of this video is to define an orthogonal vector and prove that two vectors are in fact orthogonal. So first and foremost, what I want to show here is what the definition of an orthogonal vector is. The orthogonal vector happens only when the dot product of two vectors, right, equals 0. So if you take the dot product of any two vectors that equal 0, you consider those two vectors orthogonal to one another. Well, I want to first, before we do the example, kind of compare this to perpendicular, because in a lot of different ways, perpendicular and orthogonal are pretty synonymous. I'm not saying they're the exact same thing, but they're pretty much. And the reason why I want to kind of show you the difference between them is because they result in the same thing. So let's take a look here. If you had two vectors that were perpendicular to one another, that means that the angle in between the two vectors would be a 90-degree angle. Well, we know that if we're taking the dot product of these two vectors, okay, we could rewrite this as the magnitude of the two vectors multiplied by each other, and then multiply that by, right, the cosine of the angle in between the two vectors. Well, if this is the case, what do you notice? Well, hopefully you see that this just ends up being 0 because the cosine of 90 is 0. So that's why we kind of put the words perpendicular and orthogonal kind of hand in hand with one another, but they don't exactly mean they're not, you can't just like use them interchangeably, if you will, but they do have very similar kind of results when it's all said and done, okay? So let's take a look here at an example of how we can utilize what we know now about orthogonal vectors to prove that two vectors are in fact orthogonal to one another. So let's go ahead and look at these two vectors, u and v, and we have to prove that they are orthogonal. So if they are going to be orthogonal, the dot product is going to have to equal 0. That's what we're testing. Is the dot product going to be 0? If so, great, it's orthogonal. So the dot of uv, 2, 3, -6, 4. We have -12 plus 12, which it does in fact equal 0. So we would consider these two orthogonal vectors. Okay? So again, kind of keep in mind what we're really trying to focus on is just, is the dot product going to result in 0? That's what's going to make it an